to stop there and just say that one of the things that's really exciting to me about the speakers today is the breadth of expertise on the project. So you have Aria Amirbahman from Civil Engineering, Steve Norton from Earth and Climate Sciences, Linda Bacon from DEP, Scott Williams from VLMP, a student here, Kaci Fitzgibbon, who's doing work on this. And so to me, the stakeholder mix, the mix of research expertise, oh, and of course I'm forgetting, hi Firooza, who's a professor of geography. That's exactly the kind of work that we think is exciting and important and innovative. Paper came out last week that I know something about, looking across the country at innovative programs trying to solve sustainability problems. And I think it's safe to say that the University of Maine's work in this arena looks pretty compelling, even relative to other major universities that are doing this. So welcome. I'm going to let you guys.
Well, hello everyone. Thanks for joining us today. Title of our presentation, Maine Lakes Living on the Edge, as a question mark. This is a physical science and social science collaboration that we're conducting. We're sort of relatively early in it. We started 9 months ago. The project's ongoing, and the idea is to evaluate lake vulnerability to different drivers, and also to look at what drivers basically make people more involved with respect to lake stewardship. As David mentioned, we have a very diverse group of people at the University of Maine. It's myself, Kaci Fitzgibbon. She's a new graduate student. She joined us a few months ago working on this project, and Steve Norton. We're doing the biophysical or physical-chemical part of this project. Then at the University of Southern Maine, and now, I guess, Muskie School, we have Firooza Pavri. She's an anthropologist slash geographer, if you will, and she's working with an undergraduate student, Emma Carey. Then we have stakeholder team members, and they're not just stakeholders, but they're team members. They've been involved at every stage of our work, from planning and design to execution, and now in data analysis and synthesis. At the Department of Environment Protection, Maine DEP, the Lake Management Group, we have Linda Bacon here. And our team actually has grown. Recently, Jeff Dennis and Jeremy Deeds, both biologists and lake experts at the DEP, were very interested in what we were doing, and they also joined us. We also are working with Maine Volunteer Lake Monitoring Program, the VLMP. It's a citizen science organization. Scott Williams is also integral to our team. Unfortunately, he had an emergency in Portland. He could not be with us, but Linda will reflect really his thinking. VLMP involves 1,200 volunteers. So if you will, part of our stakeholders, we have a very large base of stakeholders. Then we're also working with lake stewards, others, lake association members. We've been in contact with them, shorefront property owners, and municipalities. Now I let Linda present some background material on the stakeholders, please.
So Maine DEP is charged by state statute to determine if lakes are meeting their classification standard of GPA, which primarily focuses on trophic state. In particular, lakes are to be free of culturally induced algal blooms and have a stable or improving trophic state. We report to the legislature and EPA every other year. Tallies and acreages of lakes in various trophic categories. Attainment status is determined by using trophic parameters such as Secchi disk transparency, chlorophyll, total phosphorus, and dissolved oxygen. Lakes that are not attaining their classification are considered impaired and move to the front of the line to receive federal funds under the 319 or non-point source program to fix on-the-ground problems. We also maintain a list of lakes that are at risk due to development. These lakes are also eligible for 319 funding. In reality, the lakes themselves don't receive the money. It's local stakeholder organizations that are recipients. Not all lakes in either of these two categories have lake associations or the equivalent. Sadly, only a small proportion of lakes in the state have strong local stewardship. So DEP has about 2,800 lakes statutorily considered great ponds, and only a handful of biologists to conduct monitoring. In 1971, the Volunteer Monitoring Program was established, and it was run by DEP for the first 20 years of its existence. In the mid-1990s, budget cuts forced the program into the private nonprofit realm, and it is now known as the Maine Volunteer Lake Monitoring Program. And the VLMP is nationally a premier citizen science organization having more than 1,200 volunteers collecting water quality on over 400 lake stations. They easily collect an order of a magnitude more than DEP is able. Not only does VLMP train citizen scientists to collect water quality data, but also to identify aquatic plants for invasive plant screenings, and they also train people to conduct watershed surveys. Most recently, VLMP has organized a multi-year survey on Moosehead Lake. It involved more than 50 individuals, and it stimulated interest in monitoring in that region. Sebago Lake is next on their list. It's important to mention that the VLMP provides an incredible amount, it's not measurable, the amount of education to the volunteers that are participants in the program. And that results in local advocacy and ultimately stewardship for the participating lakes. So, next slide. So this is just a little bit of background about where this research is coming from. Back in 1998, DEP contacted the geochemists, these two gentlemen, fine gentlemen right here, to talk about some lakes that responded in an atypical manner from the model that we were used to thinking about. Anoxia generally resulted in release of phosphorus from sediments, and that nutrient could get up into the epilemion and fuel algal growth. But there were some lakes that had anoxia that weren't releasing total phosphorus from their sediments. And as it turned out, a series of projects revealed that there were some critical aluminum to iron ratios and aluminum to phosphorus ratios that Aria will talk about a little later. So various grad students worked on a small number of lakes, and about 2010, DEP really jumped on the bandwagon and began collecting sediment samples from quite a few lakes. The soil lab, I have to give Clive DeVoy credit. He ended up, previous lab manager, he ended up taking the sediment speciation technique that various grad students had used over the last decade and turning it into a process that he could have confidence in the data from. So that brings us to this project, which includes local stakeholder participation with the physiochemical data collection and the social surveys that Firooza will speak about shortly.
Great, yeah, thanks, Linda. Yeah. With that introduction, let me talk a little bit about what this project is about. Of course, this project is about the lakes, and these are great resources. I'm sure all of you have had multiple positive interactions with lakes. Lakes are truly gems on our landscape. As Linda mentioned, there are 2,800 lakes in Maine with 10 acres of area or greater. They are home to a diversity of fish and wildlife. Again, these items are all clear to all of us. They perform various ecosystem services. They trap nutrients, they trap sediment. 4 of the largest Maine municipalities take their drinking water out of lakes. So they're very important in every aspect that we can think of to the state. Lastly, the activities related to these lakes contribute approximately $4 billion a year to the state economy. Now, Linda knows all the details of where this number comes from, but I'm sure that it is significant. Absolutely, it's very significant. The threats to these lakes are multi-scale, so to speak. Atmospheric deposition is one of them. Atmospheric deposition of acid rain and mercury, of course, in the past have those depositions have abated to some extent. However, still in Maine, atmospheric deposition is the most important vector for toxic contamination of our lakes. Then there are invasive species that we all know about, series of macrophytes. We have eutrophication problems, especially in recent years with respect to harmful algal blooms, HABs, HABs. And these have to do with two factors, which are internal dynamic and land use. Our research project deals with the eutrophication issue, and we're studying the internal dynamics and land use. Then we have issues of climate change. Climate change, you can divide it into many different categories. We have witnessed extreme weather events, warming, reduced duration of ice cover, case in point, winter 2016, and longer growing season, which really follows reduced duration of ice cover, where summers are longer. Growing season with respect to algae. Here is a photo of Sebatis Lake or Sebatis Pond in southern Maine, one of our study lakes, and this is in 2014, which was actually a good year. The urgency to our work largely stems from climate change that threatens Maine lakes. Let me just go through some statistics, and these are all affect adversely the quality of lakes with respect to eutrophication. Since 1895, average regional temperatures have increased by about 3 degrees Fahrenheit. Numbers of days at which the temperatures were above freezing have increased by nearly 14. Climate models predict additional 3 to 5 degree Fahrenheit increase in temperature and about 5 to 10% increase in precipitation by 2050 in the Northeast. These all have implications. We'll show some of them for water quality in lakes. We expect more frequent intense storms, and I'll show you why we are concerned about these. There has been a 70% increase in extreme precipitation in the last 60 years, and we define extreme precipitation if we get more than 2 inches of rainfall in a 24-hour period. So that number has increased significantly in the last 60 years. Two examples. One is Lake Auburn. Steve and I, along with Linda, we have studied Lake Auburn extensively, and George's Pond. These are just two examples. Historically, very clean. Lake Auburn acts as the drinking water source for some 50,000 people in Lewiston, Auburn area. They've exhibited severe dissolved oxygen loss, fish kills, and their first algal blooms in 2012. This was a year that experienced early ice out, resulting in a long, open water season. Again, if I were water quality managers, and I'm sure they're very, very worried about it. We work with them closely, and 2016 is a year everyone's concerned about with respect to lake water quality, and also cross-country skiing. The culprit in most of the lakes that we've studied is phosphorus. Excess phosphorus in lakes is the leading cause of water quality loss. The questions that we're trying to answer. Number one, can we model lakes most susceptible to eutrophication due to excess phosphorus? Me being an engineer, I would like to have a quantitative model. I put 3-4 drivers in it, it gives me a number, and that number is correct, and that number says if the temperature is that high, if the lake has certain morphometry, if you have such a wind speed, that lake's in trouble. That lake's going to become eutrophic. So what we're after is basically a set of quantitative tools to look at certain drivers, land use related, climate related, internal lake dynamics that I'll talk about, and whether or not we can actually predict what happens to lake water quality. That's one. The other, and Linda alluded to this, is the DEP, when they're awarding funds for restoration, remediation, protection of a water body, they don't just look at the biophysical and chemical state of that lake. They also look at how involved the citizens of that lake are. Okay? So it's extremely important. So it's not just, a lake has lost its water quality that we're going to spend all these funds remediating it. It is also how involved people who live around this lake are. So then our idea is that can we gain an insight into promotion of stewardship activities at the local level? Okay? Are there drivers that lead us in the right direction? And again, the issue is that by and large, this deciding whether or not or how far citizens have been involved in lake stewardship has been largely ad hoc or more qualitative in the past. We want to see whether we can systematically look at this and whether we can again come up with metrics to quantify lake stewardship and come up with ways to enhance it. The objectives of the study. The objectives are, of course, one is to develop a lake vulnerability index, we call it, to predict which lakes are most susceptible to deteriorations in water quality. These are largely physical and chemical parameters that drive a lake to lose, its water quality or to remain pristine and healthy, if you will. Just to mention that Maine DEP has worked in the past with a vulnerability index, and that's one reason they're so interested also in this project. Jeff Dennis and Jeremy Dietz got involved when they realized what we were doing. However, their vulnerability index is largely based on land use, what happens outside of the lake. It does not consider the internal dynamics that I'll talk about shortly, and also what those internal dynamics can do or how they can be affected vis-a-vis the climate change. We have used and will be using surveys and interviews to identify factors that encourage successful collaborations among VLMP monitors and lake associations on lake stewardship activities. This is the component that Firooza is leading along with Scott from VLMP, and she'll be talking about this. One thing to mention is that, we have actually, in our sampling of these study lakes, we got the volunteers involved, and Kaci later will talk about her experience as she interacted with volunteers to collect the samples and process the samples and so on and so forth. Lastly, we would like to develop a blueprint of activities. These activities would be informed by our physical as well as social scientific findings that can possibly influence stewardship behaviors among the public. All right, so we came up with a set of study lakes. Again, the academicians as well as stakeholders. We, 5 of us sat together back in May at the DEP office in Augusta, and we came up with a 3x3 matrix of lakes across a continuum. So the columns here are the trophic state. Low means oligotrophic, or clean, if you will, and eutrophic, algal-infested, if you will, okay, along a continuum. So we have oligotrophic lakes, eutrophic lakes, and oligotrophic/mesotrophic lakes. The rows of this matrix are citizen involvement, okay? So we have lakes with what we call low citizen involvement, high citizen involvement. These are more qualitative measures. Linda knows everything about every single one of these lakes. And if you have any questions, I'm sure she's here. Yeah. And basically, High is a very active lake association. Some of these lakes, I guess, which one was it? Emden that or one lake we didn't even include because we were scared of the homeowners. They were so active and they didn't want to. I mean, that level of activity. So anyway, we have basically a total of 24 lakes. These 24 lakes, we did a complete physical, chemical assessment of these lakes, of the water sample, of the sediment, and we've done a survey of the residents of these lakes that we'll present later. Lake Environment Association, LEA, and the DEP augmented this list by another, I believe, 121 lakes. So now we have close to 130 lakes that we're chemical model. Now I let Kaci, as I mentioned, Kaci, the second round of sampling that she did in August of 2015 involved the volunteers and association members, and I let her talk about her experience.
So I first started meeting the volunteers back in August. I met with them either at the boat ramp or at their homes individually. The thing that struck me most about meeting all of them was how interested they were in what we were doing and how they couldn't wait to get results back to see what was going on in their lakes. So I came into the project thinking I was going to have to explain a lot of concepts and what I was trying to do in the lakes, and I came out of it and I feel like it was more like I was working together with them. Really nervous, sorry. Oh my gosh. They really knew their stuff. A lot of them have been working with the VLMP, and they have actually been monitoring for probably more than 5 years themselves.
Great. Yes. So basically, yeah, absolutely. The volunteers were quite knowledgeable, and we learned actually quite a lot from them, and all sorts of intricacies of the historical, for example, water quality of these lakes. We sampled, I'm not going to go over them, but we really did a very complete slew of water samples, and also we took sediment samples and we studied them at length. And I will just spend 2 slides and show you some of the exciting results we have, and then we will move on to the social science part of this. These are results of sediment extraction. So we went to each lake, we took the top 2 centimeters of these sediments, and we subjected them to all sorts of mild, all the way up to more aggressive chemical extractions. I'm not going to get into detail. The x-axis here are sediment aluminum to iron ratio, sediment aluminum to phosphorus ratio. So these are elements that are in the sediment. What these diagrams show is that if the sediment aluminum to iron ratio is greater than 3, the lake remains oligotrophic. The y-axis, by the way, is chlorophyll. So how much algae you have. So if lakes that are high in aluminum compared to iron, this ratio is greater than 3. Aluminum to phosphorus, this ratio is around 25. In other words, if you have 25 times more aluminum than you have phosphorus in the sediment, your lake water quality remains very good. Okay? Now, Steve and I are quite excited about this data because back in 2005, we were part of this study led by Yuri Kopacek from the Czech Republic. We studied in the lab some 55 lake sediments from all over the world, and lab experiments showed exactly these 2 ratios, 3 and 25. And it's truly exciting for us. And I think for the first time, at least on so many lakes, we can see the role of sediment chemistry in being able to sequester phosphorus, so phosphorus will not be removed. So, lakes that are in danger are lakes with low aluminum to iron ratio. You can see that so many of them are here. And also lakes with low aluminum to iron ratio. Aluminum to phosphorus and aluminum to iron. Now, what happens is a cluster of lakes are down here, okay, on both of them. These lakes are supposed to have bad water quality, poor water quality, except that they don't. Okay, so that's part of what our research is about. So these are sediment chemical drivers. They're physical drivers. One of the physical drivers is this number called Schmidt stability. Schmidt stability, basically, is the amount of energy that it takes, mechanical energy, as if, you're, let's say, stirring your coffee cup, you exert a certain amount of energy. The amount of mechanical energy you need to expend, of course, there's no mechanical steering in a lake. The lake, the wind does that steering for it, by and large. Schmidt stability is the energy that it takes to mix a square meter of water. What we see is that lakes that are highly stable, these are lakes that, number one, are deep, number two, have strong thermal stratification. Really warm or relatively warm at the top, relatively cool at the bottom. What we see is that lakes that are eutrophic are lakes that lose this thermal stability. These lakes are shallow or right after a hurricane. What we saw, for example, when we looked at 2011 data Hurricane Irene from Lake Auburn, we saw that a stable lake, high Schmidt stability, moved to a low Schmidt stability number because of all the mixing that was brought about by this hurricane. So these are all what we call in-lake drivers. What the DEP is supplying us with are all the land use components. Land use being how much forested land you have, how much impervious land you have, and the idea is to incorporate all of these into what we're hoping to be a predictive model such that we can look at lakes at an individual level and with some certainty say whether these lakes are susceptible to land use changes, to climate change, what kind of temperature regime, what kind of thermal stability, and basically build a model based on that. With that, I'll give the podium to Firooza to walk us through all the social science work that we've done.
Yeah, thanks, Aria. I hope everyone can hear me. And yes, so I will be talking to you a little bit about the social science component of this study. And I guess, I don't need to convince this room that, we look at any of these systems, any of these natural systems as coupled systems. And to understand these lake systems, we have to look at the social science component, especially who's using the lakes, how are they being managed, how are they being monitored. And really, when we think about it, people that live around the lake or use the lake, or perhaps even live farther away from the immediate lake, still have that connection between the lake itself and what happens to it. So there's where the social science component comes in. And in particular, in terms of the social science component for this study, I think the citizen science literature is really relevant. You've heard mentioned the VLMP group and, of course, the lake associations. And most of the citizen science literature suggests to us that really the most elaborate information that we can get about lake systems or forest systems or any other natural system is perhaps from harnessing that local knowledge that can be critical to understanding the nuances of local context and how local context plays an enormously important role in how these systems are managed. So we use a citizen science perspective to really understand what's going on the social side with our lakes. So next slide. All right. So the way we've engaged the social science side for this project is by conducting some surveys and focus groups. We've already completed 2 surveys. One is to lake associations, and the other has been sent out to VLMP members. And we've received results from both of those surveys. And so today what I'm going to do is provide you with some of the preliminary analysis from the Lake Association survey. Aria, you can
Okay. Yeah.
scroll
Okay.
all the way
Good.
through the end.
Oh,
Yes, right
thanks.
there. So what are the kinds of things that we're trying to garner information about through these surveys? We're looking at the types of monitoring and stewardship activities that these lake associations or VLMP members engage in. We're looking at the factors that influence residents' involvement in stewardship activities. What keeps them coming back? I think that's a really important component to making sure the local population is engaged. And we're also trying to understand factors that contribute to really active lake associations where there's a lot of really effective stewardship. So what sorts of networks do they develop? How do they involve external partners? Those are some of the questions that we're hoping to probe into. Next slide, please. So as I said, the surveys themselves, there are 2 of them. In the first case, we surveyed the 24 lake associations that are within our study and that you saw on the matrix that Aria that had put forward a few slides back. We had a return rate of 50% of the lake associations responded. We were hoping for higher, but we'll take the 50%. That resulted in about 111 respondents. The VLMP survey was sent out to all VLMP members, and the VLMP survey was sent out to all VLMP members, and we received about a 27 response rate with roughly 340 respondents. We're currently engaged in the analysis of the survey data, mostly qualitative content analysis with some descriptive analysis as well. So over the next few slides, what I'll do is take you through some of the early analysis that we have, just to give you a flavor for the profile of the citizens that have been very involved in this endeavor. So Aria, next slide. So here's a quick profile of the respondents from the Lake Association survey, and just a quick cursory glance at this slide will indicate to you that it's mostly males. They're mostly working, generally 50 years and above. So a slightly older age group, have advanced degrees to a fairly substantial extent, and come from a slightly higher income bracket. What's interesting is when you compare this profile to the profile that we put together from the VLMP survey, and I'm not going to share that data with you today, it's roughly similar, the only difference being the income levels are slightly different in terms of the VLMP survey. But in most other respects, they're very similar. Next slide. So one of the interesting questions, I think, that has been raised in some of the citizen science literature is really, what do we call these people that are out there collecting data? And so one of our questions posed exactly that. How would you describe yourself? And to me, the results were actually very interesting and somewhat unexpected. So as you can see from the slide, the respondents definitely thought of themselves as engaged in environmental stewardship and volunteerism, community service, much more than citizen science work. And perhaps that has something to do with the idea that citizen science is more of a sort of academic term. But moreover, I think it's sort of telling because these folks don't just see themselves as data collectors. They're really much more actively involved and engaged. And so, there's that distinction, I think, between this idea of just being a citizen scientist, or rather a citizen steward, which I think is perhaps a slightly better descriptor for a lot of the folks that we've been engaged with. Next slide. So some of the other questions we probed on was to look at the motivation factor. And motivation in the citizen science literature, there's a lot been written about it. And you can understand why, because we obviously want to keep these folks involved and coming back in the long run. So some of the things that our survey highlighted was the personal attachment factor. They were very concerned about the health of their lake. They were very involved in their lake communities. And there was a deep sense of personal satisfaction that they got from engaging in such work. Once again, I think everything that we see in the rest of the citizen science literature, but I think this idea of personal satisfaction, and the high ranking of personal satisfaction was something that was interesting to see from our surveys. Next slide. So we were also interested in what sorts of activities are citizen stewards engaged in, and obviously there's a great list up there that you can see on that slide, but primarily invasive species monitoring, plant control, SECI depth, ice in, ice out data. And in each of these cases, we have to recognize that VLMP has been critical in terms of providing the training and retraining of a lot of our survey respondents, our lake association members, etc. And it is, I think, in most of the citizen science literature that I've read, a lot of it happens somewhat on an ad hoc basis. People are trained, they go out and collect data for maybe a couple of seasons, but then there is no long-term effort, except, of course, there are always exceptions to that. In the case of the VLMP, most of the members there and these lake association folks that were involved have been involved for a long time period. 5 years, very easily, and in many cases over 10 to 15 years. Next slide. This looks at some of the concerns for the lake associations, and obviously the concerns are areas that we want to focus on because we want to know what are the things that they're observing in their own lake systems, and how might we help in terms of education, communication, stewardship activities, etc. So once again, we see two factors that stand out. One are the biophysical concerns to lake water quality, etc. And the second one were the development concerns, the usage of the lake, both by residents and non-residents as well. Climate plays, it was one of our options, but it ranks far lower. It plays a sort of lesser role in terms of their primary concerns for these lakes. Next slide, please. So then we get to beyond the sort of objective Likert type questions that we collected data on. We also had some open-ended questions, and we're in the process of using content analysis to look at a lot of these open-ended questions. And there are three that I'm going to just highlight very quickly in this session. In the first case, we asked them about the kinds of stewardship activities they were engaged in on their own lakes and what they perceived as being really successful. So it was very interesting to read the detailed sort of comments that we got back. This graph kind of summarizes it in short little bullet points. But I think there were certain themes that stood out. Nested stewardship efforts, basically different organizations working in concert with each other, perhaps land trusts, with lake associations, with the VLMP, etc. They saw those as important. They also saw very, very important the constant monitoring and surveying activity that were being done. So the data collection was actually an important component of that as well. They also identified the involvement of different groups of sort of their own lake association members. So not only a wide variety of members from within and around the lakes themselves, but also involving the youth into different activities as a really important part of successful stewardship activities. So we have youth conservation core efforts, etc., that we often see collaborate with these lake associations to engage in maybe summertime activities and that sort of thing. Next slide, please. So the second question looked at the critical factors for effective stakeholder involvement in lake stewardship activities. So what lessons can be learned from those lake associations that might be fairly successful in terms of stewardship activities, and how do we take those lessons and apply them elsewhere? The themes that emerged here were education, communication, outreach, follow-up. Something obviously that I think most of us are already aware of, that is critical to involving stakeholders and keeping them engaged. An active volunteer community, so having a core group of volunteers who's very active and dedicated, and basically does, leads by example in a way. Essentially, their work in the community urges others to join in as well. That was one of the themes that we saw. And then seeing the results of the work that they do was a strong motivator. So if they saw the results in terms of some stewardship activity, that was a strong motivator to keep doing that. Whether it was harvesting or removing invasive species or whatever have you. And also the idea of having a strong leader for the group, providing that sense of direction and community was identified as an important component. Next slide. And finally, I'm not going to spend too much time on this, but sort of building on the previous slide, the factors that keep lake associations active and keep them doing what they're doing. So being able to see the results, something that I talked about, willing and engaged volunteers, and good communication as well. Next slide. So to summarize, and this is just the survey analysis from the Lake Association surveys, to summarize, we're seeing certain themes emerge. Number one, that in terms of the respondents that we've got back, and they are somewhat self-selected, obviously because they have taken the time to respond to our surveys, there is, however, a very high level of commitment that we find in the work that they do. Very important to sustained efforts was the idea of education and communication and constantly engaging in that process. We also saw that building social capital, self-organizing lake associations, building those nested relationships and networks can be really critical to making sure these lake associations are successful in their efforts. And I think we see that in some of the survey results that we get back is they talk about the networks that they've developed and built and how important that is to continue the work that they're doing. Deliberate and collaborative efforts rather than something that's ad hoc. So that was another theme that we saw emphasized. And in that case, they especially talked about the role of leaders and the critical role of leadership, good leadership, in allowing these efforts to continue. The involvement of the younger generation, I think we saw a lot of survey respondents that bemoaned the fact that there weren't as many younger folks involved in this kind of work as they would like to see. However, they believe that really bringing in that younger generation is critical in the future. And then the role of supporting institutions like the DEP and land trust organizations, etc., as really critical. So that's kind of the preliminary survey analysis, and we're still, we've got a lot of data to dig through and put together, and we're launching into the VLMP data analysis, and I think that's going to give us a rich insight into those members and how they perceive a lot of these issues. Next slide. And then finally, just to wrap up very quickly, we'll talk about some of the next steps that we're going to be engaged in over the next few months. So like I said, the analysis of the VLMP surveys. We are also in the process of organizing 2 focus groups that we're going to engage in during the month of April. And this is basically to go back and probe further some of the questions that were raised in the survey data. So we'll be engaged in those focus groups with our Lake Association representatives, and I think that's where Kaci's help will be tremendous, because she has that connection with a lot of Lake Association reps. We'll be finalizing, and that would be Aria's side, we'll be finalizing the physiochemical model. And then finally, in the month of May, hopefully, we're able to hold some informational sessions where we should the results of our study, and also hopefully in the future able to conduct workshops on best practices, knowledge between what we learned and different lake associations, etc. And I'll leave it at that, and perhaps Aria, I don't know if you have any further concluding thoughts that you want to add.
No, I guess
to this.
unless we're fine. Yeah. So, thank you very much for your attention, and we're open to questions. Please.
I have a question about the boat ramp surveys, and I was wondering if when you approach people, in the SPAGO we often found that they went immediately to issues with water depth and clarity, mostly water depth, to see if they could get their boat into a dock or not. And at the end of it, I was summing it up on some of the issues were, how far can I walk out until the lake's over my head, and can I see my feet when I get that far out? And I was wondering if the people that you ran into were obsessed with the same smaller sets of topics based on what their typical activities were, or they broader thinking about a lot of other things in the lake.
I think their major concerns were sort of phosphorus blooms in the lakes. Mostly I did meet people at like their houses. There were very few I actually met at the boat ramps, so not a lot of them had concerns about the boat ramps. But I don't know if that's in any of the surveys, so that might be different.
No, I didn't see that sort of occurring in any of the surveys.
All right.
So it looks like more aluminum is better in some respects, but also it was a concern back in, we were really concerned about acid rain. So are you going to dump aluminum in lakes?
Well, engineers discovered many years ago in sewage treatment plants that if you had high phosphorus, you could add alum, which is an aluminum sulfate compound. And the aluminum sulfate is very soluble. You get ionic aluminum in the water column, it precipitates, and it precipitates what we would say quantitatively. All of the aluminum virtually precipitates, and when it sediments out, it scavenges phosphorus from the sewage treatment process, or in this case, naturally in lakes. So this is really tertiary water treatment going on in our lakes, but we didn't know it. And the amount of aluminum in solution in equilibrium with these alum treatments, and there have been how many done in Maine?
4.
4 lakes in Maine have been treated with alum. The aluminum is trivial in the water column because at pHs between about 6 and 8, you can't dissolve virtually any aluminum in the water. So aluminum, when it's in solution, is problematic, but in most lakes it precipitates and you have nothing but solid going to the sediment water interface.
That's why I loved your class, Steve, because you make it all seem very simple.
Well, it is. All science is simple after the fact. But getting there wasn't.
Linda, I'd be interested in hearing how the state's approach for vulnerability assessment differs from the approach that's being taken here, and whether or not there will be a coupling of those things that are happening in the watersheds with the in-lake processes.
I'll answer the second part of your question first. The answer is yes. We had a pretty intensive discussion, 4-hour discussion last Friday at DEP about merging the approaches that the state has taken with this new model being developed. We pretty much started off, we being the state, with the Vollenweider model, which dealt with only hydrology. And then we began to add land use, but we got to that by population increase. So we had the hydrology, and then kind of a crude land use, but didn't think about the in-lake processes at all. Hopefully what will come out of here is something that will consider hydrology and more detailed evaluation of land use and population, GIS-based rather than just census stats, coupled with the in-lake aspects.
Just one other question. Are the ratios that you're seeing in lakes independent of factors in the watershed? So in other words, if over time you were to see increases in deleterious land uses, might those impact the ratios, or are they independent?
The thing that's probably most susceptible to being changed is phosphorus because of land use. So if you add phosphorus releasing activities to a watershed, agriculture, just disturbance of the landscape itself, various industries that don't control their effluent, but now they're all required to. But that would be one way to increase the phosphorus and thereby shift the aluminum to phosphorus ratio. And at the same time, if the aluminum to iron ratio were in that sensitive 0 to 3 range, then adding phosphorus is the worst possible thing you could do. So we should be able to identify those lakes that are teetering. They've got low aluminum to iron ratios, but they're not yet releasing phosphorus when they go anaerobic. But we do have several lakes that are oscillating between two states now, releasing phosphorus, such as Lake Auburn, and part of the time not releasing phosphorus. So it's hard to change the amount of aluminum. The aluminum comes from wetlands, largely. It has to be dissolved when it gets to the lake, and then it precipitates in the lake by processes that will take me at least 20 minutes to explain, so we won't go there. But wetlands are going to turn out to be a very important component of the sensitivity of a particular lake, because the wetlands deliver aluminum to the lake, which is good.
But they also deliver a lot of iron to the lake.
Yes.
That's not very good.
And high methyl mercury.
Yes. Yes.
True.
Yes.
True. Yes, please.
A question for you, Firooza. I'm wondering if your survey questions address people's willingness, or the Lake Association's willingness to tackle the really difficult problems of changing land use in the watershed of the lake. Relatively easy to monitor, relatively easy to kill invasive species, but telling farmers to do something differently challenging. And I'm wondering if you ask questions that would indicate people's willingness to tackle that kind of thing.
Yeah, that's a good question. No, we did not include those sorts of questions on our survey. Yeah, we were very much focused on activities on and around the lake immediately rather than across the watershed. But yeah, that's a tremendously important component of what happens in lakes as well. So it's interesting. Perhaps something. I'm putting together the questions for the focus group right now, and maybe this is something that we can explore a little more.
Ms. Musi.
One question is that you showed the Schmidt number as well as the aluminum phosphorus ratio. For which season is that?
August. They're all August. Yeah, sediment characteristics do not change as much, but Schmidt stability is a snapshot in time. Yeah.
If you think about Maine lakes, most of them turn over twice a year, and the Schmidt goes to 0 when that happens.
Right. So that was my question. And my second question is that I would have expected that the more the stratification period is, then you see more those algae blooms, because the more stratified it is, then there will be more anaerobic processes as well as you will have more phosphorus within the lake.
Yeah.
But it's counterintuitive that your result shows that those lakes which have lower Schmidt number or lower stability have a higher algae problem, while those which are stable have a lower.
That's a great question. This was going to be my question from you on your PhD defense exam. But since you asked, yeah, that's a very good question. Do you want to answer it? Basically, what happens is if you wait for phosphate that's released from the bottom sediment to diffuse 30, 40 feet, it takes a long time. Okay, because phosphate has to diffuse more or less where there is sunlight coming in. Okay, for photosynthesis to take place. Diffusion on its own is very, very slow. But if you mix things, even a little bit of wind, that enhances diffusion. So part of what you see, low Schmidt stability, it's not that those lakes are not stratified. They are stratified. It's just that the difference between top temperature and bottom temperature is a little less. So a little wind can induce more mixing. That's number one. The other thing is, and that's something that actually our collaborators in DEP, Jeff Dennis brought up, that if you cannot measure an oxygen on a lake, it doesn't mean that it's not. See, when we sample lakes, we get to 1 meter close to the bottom. We don't go below that because we can entrain sediment if the camera hits the bottom. This doesn't mean that you have a small layer at the bottom that's releasing phosphorus. It's not that we don't see it. And I think this is exactly what happens in Sebattis Lake, one of our most polluted lakes. You saw that, or eutrophied lakes. When Kaci sampled it, it was all oxygenated, but it released a lot of phosphorus. I think that was just really, really thin layer that we could not measure, but then that was just released so easily.
So I'm going to take one last question. I bet it's not biogeochemistry, but we'll wait.
Okay.
Yes, it is. I provided her with one.
This is really great and really interesting. So my question is about citizen science, and I guess it's a reflection maybe more than a question. Right now at UMaine, there are graduate students doing dissertations using citizen science across very different areas. So there's someone doing a bees dissertation, there's somebody doing a dissertation on elder issues, somebody doing wind power, somebody in education. How are we all talking together? Because we can learn so much from each other. And these are going to be really, really interesting dissertations.
Is that a comment or a question?
That's it's a great comment, and I think I wasn't aware that there were that many dissertations that were focused on citizen science, or at least involving citizen science data collection efforts. I think maybe more sessions at the Maine Water Conference would be one way to get all of these people talking together. Perhaps a panel, I hope, something like that. But certainly we should capitalize on these efforts and share knowledge and whatnot.
And if I can comment on that, I guess most of you, a lot more than I am, are familiar with the SES framework laid out by Eleanor Ostrom. I think the SES framework, social ecological system framework, they lend themselves, or lakes lend themselves very well, I think, to analysis using that. And I wrote these 4 down, lest I become like Rick Perry. I forget half of them. They're only 3. Okay, all right. First level indicators, the core, are resource systems, which are in this case are the lakes themselves. Resource units that are probably not just fish and wildlife, but people's properties. Users who are residents, vacationers, whatnot, and you have governance system, the 4th one. And the governance system could be anything from the DEP to the local, homeowner association. What she does in her 2009 paper is she basically provides a framework where social science findings and physical science findings can all be integrated into this larger model. I believe that we had a speaker here, Heather Leslie, a few months ago. She had implemented a very interesting study of fisheries along the Sea of Cortez, in Mexico, and the same, social science, physical science. And when I went through her second tier indicators, like predictability of resource dynamics, that's exactly what our physical science part is trying to do. We're trying to predict these resources, the health of these resources, or productivity of the system. I mean, I think these can also be all integrated into a unified model. Again, an engineer is talking to you right now. Model is good for everything, but I think if we're going any further integrating what we're talking about, I think we really need to look at that direction.
So, taking the moderator's prerogative, I would just like to say that when I first met Aria 10 years ago, if I'd been asked to make a bet about the likelihood that he would speak so eloquently about the work of Elinor Ostrom, who, by the way, not only was the first woman to win the Nobel Prize in Economic Sciences, but sat right about where you are, Amanda, and met with many of our students here not too many years ago, I would have lost a big bet. So, Aria, way to go. Great job, everybody. Firooza, thanks. Wonderful. I'm going to follow up. I've got lots of questions.
Great, thank you so much.